So this is what our example that we have been looking at, and remember our second question, we need to know the probability of having a negative NPV. So when we are looking at the probability of having a negative NPV, we are going to look at this. First, we are going to look at this and this. So where we are having this, which is 91 and 41, then we are having 91 and 83. So if you look at this and this, we are having 0.12, this and 0.3 and 0.6, it gives us 0.18. So if you look at this and this, remember our initial investment is 350. So if you get this, our cash flows here, which is 91 plus 41, automatically this branch you are having a negative. So even if you take this branch, that is 91 plus 83, you still have a negative because our initial investment is 350. So it means from here to here, that is 0.3 times 0.004, you get 0.12. It is negative. This one, 0.3 and 0.6, still is giving a negative. Then we also have 0.6, because if you have 182 plus 165, you have how much? That is 347, and still it is a negative. Then we have 182 plus 330, it becomes 512. So this one is giving us a positive. So the only probability that is giving us a positive is 0.2 times 0.6, which gives us 0.48. So meaning the probability of having a positive cash flow here will be 0.48. So the probability of having a negative cash flow will be 0.42. This is what we have talked about, so we are not repeating it. So I want you to take you to the second method that we can use, which is a payoff table. So in a payoff table, as discussed, the first step still, you need to get the present value cash flows. So this is our probability. In year 1, we have 0.3 and 0.7. And this is the cash flow in year 1, and this one is the cash flow in year 2. So this is in year 1, remember our PV factor is 10%. So meaning that our PV factor of 10% in year 1 is this for this one. So you can get our present value cash flow. This present value cash flow, you are getting your cash flow times your PV factor. So you get 91 and 82 in year 182 in year 1. When you come to year 2, or if you go to year 2, the probability changes. If your probability was 0.3, you still have, there are chances that the cash flow can be 50 when the probability is 0.4, or 100 if the probability is 0.6. So you still have, if the probability was 0.7, chances that cash flow can be 200 if it's 0.4, or it can be 400 when the probability is 0.6. So you can still get our present value cash flow in year 2. So still we have the same PV factor, which is 10%. So 10% here, 0.826, 0.826. So you can multiply here to get your present value cash flow in year 2. So once you get the present value cash flow in year 1 and year 2, the next step is to construct what we call a payoff table. So in our payoff table, so we still have the probability, which is 0.3 and 0.7. This is our cash flows in year 1, 0.9, and this is 0.9 and 182. We go to them from the other table. So in year 2, these are the probabilities in year 2, and our cash flows in year 2 are these ones. Now, what we do is to get our total cash flow. So when we are getting the total cash flow, we first look at year 1. Year 1, our total cash flow in year 1, remember we have these chances. It can be this plus this, we will get 132, or it can be 91 plus 83, and you get 174. That is when the probability is 0.3. If the probability is 0.7, it can be this one plus 165, and you get this, or it can be 182 plus 330, and you get this. So that's how we get the total cash flow. You look at the first probability, which is 0.3, and look at the cash flows that are related to 0.3. Then you go to cash flows to probability of 0.7, and you get the cash flows that are related to 0.7. So we get 91 plus this, we get this, 91 plus this, or we get this one. Then for 0.7, it can be this plus this, we get this, or it can be this plus this, and plus this, and then we get this. Now the next step is to get what called the joint probability. Still, you look at the probabilities of 0.3. So the probability of 0.3, it can be 0.3 times 0.4, where we get this, or it can be 0.3 times 0.6, and we get this. So we go to 0.7, it can be 0.7 times 0.4, and we get this, or it can be 0.7 times 0.6, and we get 0.7. Now the next step is to get the expected net present value by getting the joint probability times your total cash flows. So in the period 1 or 0.3, we have this times this, we get this, or we can have this times this, we get this. In 0.7, we have this times this to get this, and this times this to get this. So then you add to get the total expected present value. Now to get the net present value of the project, or to get our net present value, or what called the expected net present value of the project, will be our total expected present value, which is this, then minus our initial investment, which is 350. Then it means in this case you are going to accept the investment. The investment is positive, so you can accept. Now, how do we get the probability of having a negative cash flow or a probability of having a positive cash flow? So what we do is to get our total cash flows that we have here, then minus the initial investment. So we are getting, for example, in period 1, we are getting 132 minus 350. We get this. Remember, 350 is our initial investment. You get 132 minus the initial investment of 350, then we get this. We get 174 minus initial investment of 350, we get this. You get 347 minus initial investment of 350, we get this. We have 512 minus initial investment of 350, we get this. So you see that for this 0.12, we have a negative. 0.182, we have a negative. 0.28, we have a negative. So the probability of having a negative will be the summation of these three, which gives us 0.58. And the probability of having a positive is only 1, which is 0.42, which is similar to what we have discussed in our previous slide when we are using a decision tree. So another technique we have not talked about is a discounted payback period. What called discounted payback period? Remember in our previous videos when we are discussing disadvantage of payback period. Payback period is a good technique, but its main disadvantage is that it does not consider the effect of time value of money. So in the discounted payback period, we now try to incorporate, or we now try to look at how to solve the problem of time value of money. So in solving that, we first discount our cash flows. Then after discounting our cash flows, then we accumulate to get the net, the payback period, or the discounted payback period. So let's look at this example and then see how to do it in practice. So I'm going to copy this part, this question, and then take it to my Excel and then solve this to see how to do it practically. So we are looking at how do we compute the adjusted present value. So you can compare these two. In the blue one, we are looking at the normal payback period. So this is our period. This is our cash flow. So this is how we accumulate, as we saw in our previous video. You begin with the initial investment plus cash flow in year 2, you get this. Cash flow in year 2, you add, or this accumulated plus the cash flow in year 2, we get this. Then this plus this, we get 0. So meaning this project, if you use the normal payback period, it will cover the initial investment in year 3. Now, but if you turn this to a discounted payback period, if you're using a discounted payback period, the first step is to discount your cash flow. And remember, our discount factor is 20%. So we get the discounting factors of 20% in this 5 period. So we get the discounting factor, then multiply by our cash flows. So we get these cash flows. Then after getting now we get what called the discounted cash flows. These are discounted cash flows. Then after getting the discounted cash flows, then you accumulate in the normal way we do our payback period. So you accumulate. So year 1, year 0, that is our initial investment, plus the cash flow in year 1, we get this, plus the cash flow in year 2, we get this, plus the cash flow in year 3, we get this, plus cash flow in year 4, we get this, plus cash flow in year 5, we get this. So if you look at this, it means if you use the discounted payback period, this project can never pay back. In 5 years, it will not pay back. So you need to look at the other decision what to do, because if you discount the cash flows, the project is not paying back. So that is how we do it, or how we use the discounted payback period. So that is how we discount, or that is how we adjust for risk in our investment. Remember where we started, the sensitivity analysis, and I said in sensitivity analysis you are looking at how the variable that was used to determine the NPV will change before NPV becomes 0. And we said you get the NPV divided by the present value of that variable. Then you can get the sensitivity. The higher the sensitivity, the higher the risk. The lower the sensitivity, so the lower the sensitivity, the higher the risk. And the higher the sensitivity, the lower the risk. Now, we also looked at the certainty equivalent factor. And in a certainty equivalent factor, I said you first get adjust your cash flows with the certainty equivalent factor. Then after adjusting the cash flow with the certainty equivalent factor, then you discount your cash flows using a risk-free rate. Then you can get your NPV. The last part that we have looked at in this video is probability. We looked at how to determine to adjust for probability. In adjusting for probability, you are looking at the probability and then multiply by your cash flows to get the expected present value cash flows. Then after you get the expected present value cash flows, then you can determine the expected net present value. So we looked at 2 methods that you can use if you have cash flows that are more than 1 year or 1 period, where you can use a decision tree, or you can use a payoff table. So we have looked at those two methods, using a decision tree and using a payoff table to determine the expected net present value, or to determine the probability of having a negative cash flow or having a positive cash flow. So please, that's the end of this part of risk in investment appraisal. So in my next video, we are going to look at the buy and lease decision in investment appraisal. Please don't forget to subscribe to my channel to continue watching my video and to get notification for my new videos.